Good afternoon, everyone, and welcome back to another episode of our Aquarium Online Academy. My name is Sarah. I work in the education department here at the Aquarium of the Pacific in Long Beach, California, and we have a really great program scheduled for you today. Oh, I've got a little friend right here. He's got a little message for you. He wants to welcome you to our Crazy Crustaceans program. So this is a new program that we're doing here, and we're going to learn all about crustaceans like this little animal here, which is krill. Now, we're going to talk about what a crustacean is first. We're going to talk about some of their adaptations. So some of the special things on their body that help these animals survive in their habitat. And then we're going to talk about a couple different crustaceans, krill being one of them, and a couple other animals that we have here at the aquarium. So what is a crustacean? Let's think about that. Have you heard that term before, a crustacean? So examples of crustaceans are animals like that krill, but also things like lobsters and crabs, and even animals called barnacles. So what makes these animals special? Have you seen them before? Let's see if we can bring up a picture of one of these animals behind me. So I'm not alone here in the studio. I have Cynthia, who's controlling the screen behind me. And I have Dana, who is on the computer, and she's going to be taking any questions you might have. So while we're exploring today, while we're learning about these maybe new animals, if you find you have any questions or there's something you want to talk a little bit more about, you can text us at this number right here. It's 562-286-1838. So go ahead and text us those questions. Now, if you're one of our younger viewers, make sure you have adult permission, and do keep in mind that text and data rates do apply. Now, if you're watching this program and it is not July 21st at 1 p.m., you can email us with this email address that's just below the phone number. It's live@lbaop.org. So you can still ask your questions, but we're going to ask that you email them to us instead of texting because we're not always on that text line. But if you have any questions right now, go ahead and text them into us on this number. Now, behind me right here is a picture or an example of a crustacean. So what do you notice about this animal? So they live in the ocean. They're they can be marine animals. But what is special about maybe their body? What do you notice? So thinking about a lobster, or this right here is called a pelagic or a tuna crab, they are special things on their body. Now, crustaceans are part of a group of animals called arthropods. There's a lot of big words, right, we're going to throw at you. And arthropod means jointed limb or leg. So if we look at their legs, they've got all these joints in it. Just like with our arm, our elbow has a joint. All our fingers have a joint. Our knees have joints. These animals have jointed appendages. And that's what makes them arthropods. Now, crustaceans are a special group of arthropods. And we're going to talk a little bit more about what adaptations, what special things these animals have on their body that help them or protect them in their habitat or their environment. So crustaceans, like our crabs or lobsters, one of the biggest things they have on their body that sets them apart from most other animals is this hard exoskeleton. Ooh, there we go. We've got a bigger picture here. Have you heard that word exoskeleton before? What do you think an exoskeleton means? So it has to do with their skeleton. So thinking about our skeleton. So maybe their bones or what gives them structure. But that word exo, do you think that means it's inside their body or outside their body? If you said outside, you're right. So an exoskeleton is a skeleton on the outside of an animal's body. So crustaceans, they are part of the group of invertebrates. So they don't have true bones like us. They do have hard parts on their body, but their skeleton is going to be on the outside of their body. Now, there's something really cool about animals with exoskeletons, about our crabs and our lobsters. Something that might be kind of shocking to you, but it's something so neat and why we like to call these animals crazy crustaceans. And it has to do with that exoskeleton. So think about, for you guys, when you might be in first grade or second grade or third grade, whatever grade you're in, and as you start to grow taller and taller and taller, your bones grow with your body. You don't have to go to the store and buy new bones, do you? No, we don't have to, because our whole body grows together. Our muscles grow with our bones, and our whole body grows together. But animals with exoskeletons, like those lobsters and crabs, their bones or that exoskeleton doesn't grow with their body. So what happens is they do something called molting. Have you heard that word before, molting? So what molting means is these animals are going to take off those exoskeleton in order for them to grow bigger. Now, we're going to in just a minute, we're going to show you a video of what this looks like. But first, I want to head over to my document camera. And I have an exoskeleton from a California spiny lobster right here. So this lobster right here, it's not alive in the studio, but this also isn't a dead lobster here. This is what we call the molt or the exoskeleton from this lobster. So what happens is maybe this lobster is 1 year old and it's eating food, it's moving around, it's doing what 1-year-old lobsters do. And as it grows, its body's going to grow. So its muscles grow, its stomach grows, its eyes, its brain, its antenna, all those parts inside its body grow. So they keep getting bigger and bigger and bigger. But that exoskeleton that you see right here, this is just one size. So as the body grows bigger, it gets really squished. Now, is it comfortable to be squished? No, it's not really comfortable to be squished in. So what this lobster is going to do is they're going to push really hard right here on their body. You can kind of see where their body meets their tail. They're going to push really hard on that body, and they're going to break that shell or that exoskeleton, and then they're going to push their way out. And they take their whole soft, squishy body with them, leaving behind their exoskeleton. So this is just like the old bones of our lobster. Think about it like your shoes. If you're wearing shoes or if you have a pair of shoes near you, look at your feet. Your feet are one size right now, but your feet are going to keep growing. But do your shoes grow with your feet? No. So you need to go to the store and buy new shoes that are going to fit your bigger feet. And lobsters, they're not going to go to the store and buy new bones, but they're going to remove these bones, and then they're able to grow new bones on the outside of their body. Kind of like if we're running outside and you fall and scrape your knee and you have a cut on your knee, and then it scabs and then new skin grows over that. So just like we get new skin growing over a cut or a scrape, our lobsters can grow those new bones. All right, I'm going to step off, and we are going to play a video so you can watch what it looks like when a lobster or a crab, this one is a crab, when they molt. Now this video was taken here at the aquarium, and this is a spider crab. And this video is sped up. So this whole process of molting for this crab took about 40 minutes, but we have sped it up into about 2 minutes. So they sort of break open their exoskeleton towards the back, and they pull their whole body out. Even their eyes, they pull out. They have a little covering over their eyes, and so they pull out their eyes with their body and all their legs. So you can see this is a live crab right here, and this is that old exoskeleton. Pretty cool. So this process, like I said, for this crab, it took about 40 minutes. The time can range depending on the type of crustacean and also the size. Now, when these animals are little, they're going to molt a lot more often as they grow bigger. But when they're more adults, they molt a lot less often as their bodies are a lot bigger. Now, we have a couple questions that came in, so we're going to pause and talk about these questions. So River wants to know, what is the largest crustacean? So in terms of pounds, like weight, the American lobster can weigh up to 44 pounds, which is like a mid-sized dog. If you think about a dog, they can weigh about 44 pounds. So that's a large lobster. But then the longest, the biggest, if we're talking about length, is going to be the Japanese spider crab. And we're going to talk a little bit about, here's a good picture of the Japanese spider crab. And we're going to come back to this crab and talk about it a little bit later. Now, we had another question is, how long do lobsters live? And again, this will depend on the species. So Japanese spider crabs can live about 100 years. There are some lobsters that can live about 140 years. And then things like California spiny lobsters, another lobster we're going to talk about later, they only live about 50 years. So it really just depends on the species. And it looks like we have another question coming in. So this question is, what is that exoskeleton made of? So maybe we'll go back to our document camera for just a second. So this exoskeleton is made, it's a mix of chitin and calcium. So it's these really hard materials, sort of like what our nails and our hair are made of. It's very similar to that. So it's not quite bone like in our skeleton, but it's not quite shell. It's sort of this mix of materials that provides a nice cover for their body. So that's another thing to talk about, is why do they have this exoskeleton? Right? I mentioned they're invertebrates, and invertebrates don't have those skeletons or that structure inside their body. So inside the lobster's exoskeleton or the crab, they're really soft and squishy. So that exoskeleton provides some protection for them. Now that means that when this animal molts, in between their molting and growing their new exoskeleton, that animal is very vulnerable. That means it's really easy for predators to get it because that animal's body is soft and squishy. So what happens after that crab or lobster comes out of their exoskeleton is that animal is going to pull in water into their body and basically puff themselves up really big. And that way, when they grow a new bone or new exoskeleton outside their body, it gives them some room to grow inside that exoskeleton. So they puff themselves up really big, full of water, and then they're going to sit for a couple days, and they're not going to move at all. Do you think you could do that? I bet mom or dad or teacher would love if you could sit for a couple minutes and not move, right? But we're pretty squirrely and we like to move around and interact with people and talk and eat. But our lobsters or crabs, they're going to sit for a couple days and they don't move at all while they grow that new exoskeleton over their body. Now, there are some of lobsters and crabs who will actually start to eat parts of their exoskeleton, and that just gives them more calcium and chitin material to build their new exoskeleton. So they'll sit and wait for that new skeleton to grow on the outside of their body, and then they're nice and protected. So that's one of the big adaptations that these animals have, is they have that exoskeleton, that hard shell-like material that covers their body, and it protects them and it makes it harder for predators to get to them. But is that the only adaptation that crustaceans have? Let's take a look. I'm going to have Cynthia put up a crustacean that maybe has something special on its arms or its appendages. What do you think I'm talking about, going like this right here? When we think of crabs and lobsters, we almost assume that they're going to have pinchers, claws. So right here, this is a decorator crab, I believe. Spider crab. This is some type of crab. It's most likely a spider crab, which is a type of decorator crab, and they have pinchers. Now, what do you think their pinchers are used for? What do you think they might use those pinchers for? Maybe you can share with someone next to you, or think in your brain, or share with us, just shout it out at the TV. What do you think their pinchers are used for? If you said grabbing their prey, ooh, here's a good picture of some nice pinchers. You're right. So lobsters and crabs can use their pinchers to grab their food and also for protection. Do you think you would want to go near an animal that's got big claws like this? I certainly wouldn't. So their claws are used for protection. Now, not all crustaceans have claws. Like the California spiny lobster, which we'll talk about in a minute or two, they don't have any claws. So they rely on other things for adaptations. But a lot of crabs and lobsters do have these pinchers to help them protect themselves. Now, we talked about two adaptations so far, the exoskeleton, that hard covering. We talked about claws. Now, there's a couple other crabs, like I mentioned, this type of crab called a decorator crab. Now, the decorator crab, what they'll do is they will try and camouflage. So that's another big word. What does camouflage mean? To do what? Well, if you said it's to blend in with your surroundings or to hide, you're right. So there are some crabs called decorator crabs, and what they do is they walk around the ocean floor and they look for little shells or little anemones or little maybe worms, and they'll pick them up and they'll stick them to their back. And that way they think they can blend in with their surroundings. Now, some crabs are really good at this, but we have a really good video. It's probably one of my favorite videos of a crab that thinks it's doing a really good job of hiding, but it's not quite doing such a good job. So take a look at this video. Look at this little guy. So this crab has grabbed a piece of kelp right there and thinks it's hiding really well under this piece of kelp. I wouldn't have the heart to break it to them. They're not doing the best job. But this crab thinks it's hiding with that piece of kelp that it's attached to its body. It's so cute. So decorator crabs, their goal is to hide amongst their surroundings, whether it's to blend with the color or with just the environment around them. That is their goal. Sometimes not all crabs kind of make it as far as that. But that's another adaptation, is these crabs can attach things to their body to help them blend into their habitat, their surrounding. Now, talking about habitat, where do we find these animals? Do you think they all live in one place in the ocean? Or do you think they can be found all over? Well, if you guessed all over, you're right. So we do have a lot of crabs and lobsters and other crustaceans, like I mentioned, an animal called a barnacle, that can be found in the tide pool. So those are along the coast where there's lots of rocks and the waves come crashing over the rocks. So we find a lot of those animals that make their home along the rocks or even in the sandy bottom, like you see here. But there are some crabs, too, who make their home in the open ocean or even in the depths. Now, I'm going to see if they can bring up a picture of a pelagic crab or red crab or tuna crab. They've got a couple different names. I think it's on the Mac. There's a couple. And these crabs, they're called pelagic crabs. Now, this word pelagic means open water. So these crabs can be seen in the hundreds or thousands kind of floating through the water column. And they use their tail to help push them through the water. And I also think they always look like they're ready to stand guard. but they are found in the open water. Now, sometimes they will wash up on shore if there's a storm or a big surge in the current. They can wash up on our shores and we'll see them then, but they can be found in the open water column, whereas some crabs will be found more in the depths or some will be found in the tide pool. So let's see, we'll take a look at our red crab. We'll get a picture. Now these crabs, they do have pinchers and they've got this bright red color to the body, but they're only about this big. Here we go. So this is called a tuna crab or a pelagic crab, has a couple different names. And they will live in these big groups and you'll see them in swarms moving through the water. So you can see they have these big pinchers right here. And they have this exoskeleton that covers their body. And then tucked in right behind here, you can kind of see it behind this leg, is their tail. And they'll actually use their tail to kind of scoot like this. And that helps them swim through the water. Excellent. So that is our tuna crab. So that's a little bit about where crabs live. But now let's take a closer look at 3 different species of crustacean. So we're going to take a look at some of the smallest, and then sort of mid-size, and then we're going to take a look at the largest of the crustaceans. So we're going to start with my little friend right here, krill. So this is a stuffed krill, and it is a lot larger than krill can actually be. Now there's about 85 species of krill, and they range in size from 0.4 inches to about 8 inches, but they generally around the 5 or 6 inch range. And we're going to take a look at my document camera, and we can get a closer look at some krill. This right here. See if we change the lighting. Oop. There we go. So take a look. All of those little things in there, these are all little krill. They're kind of like little shrimp, which are another kind of crustacean. And krill is really important. We talk about krill and as it's a planktonic animal, which means it's kind of free floating in the water. And we talk about plankton and things like krill being the backbone of our ocean food web. And that's because these animals are really small. They're found in great abundance. So we find these massive swarms of this krill, and they feed a lot of animals. Now, have you heard about krill before? Can you think of any animal that might feed on krill? So I'm going to give you a moment. Text in your answer if you have an idea of what eats krill, and I'm going to take a look at some questions we got. But think about what animals eat krill. Now I'll give you a hint. This animal is really small, these krill, but there are some massive animals out there in the ocean that feed on krill. All right, let's see some questions. Ruby wants to know male versus female. How do we tell? So that's a great question, Ruby. And my friend Dana gave me a couple pointers to explain it a little bit better. So for lobsters, it's the 5th leg on the female is forked and it handles the egg. So if we look at the underside of a lobster, we'd have to flip it over and we'd have to look at their legs on the underside. Now these animals, I'm going to throw another word at you. These animals are what we call decapods. Now deca means 10. So that means they have 10 appendages or 10 legs, 5 on each side. And for those that have pinchers, those are considered part of that 10. So when looking at their legs, you may count 8, but if they have pinchers, that's 9 and 10. So if you look at the 5th leg on the female, it's going to be forked, and that helps hold the eggs. And then you can actually see when a female has eggs because they're all on that underside of their tail. Now, I had this lobster. I'm going to just bring it onto camera. This lobster right here, this is where you would find all the eggs for the female if they had eggs. And the eggs are a bright red color, and they can lay, those California spiny lobsters specifically, about 68,000 eggs at one time. And it takes about 10 weeks or so for those eggs to hatch. So the female is going to hold on to those eggs for that whole time until they hatch. And then when they hatch, they're teeny, teeny, tiny little animals. They're considered plankton because they're just floating. And eventually they'll grow and settle to look like the lobsters or crabs like we were looking at. All right. And then for another question, Dylan wants to know, how do lobsters find new exoskeletons? That is a great question. So lobsters are not actually going to look for a new exoskeleton. They're going to grow it on their body. Now, if you think of an animal like a hermit crab, which is a type of crustacean, so that hermit crab's body, they're going to lose that exoskeleton, but that shell that they carry on their body, that is not part of their actual body. It is their home, but it's not part of their body. So as a hermit crab grows, they have to find a bigger shell. But these animals that are molting those exoskeletons, when their exoskeleton comes off, their body can produce that new exoskeleton, similar to the way that we have layers of skin, and if we scrape off a layer, we're going to grow a new layer of skin over that scrape. And our lobsters and crabs and the other crustaceans, they can regrow that layer of their exoskeleton over their body. Question. All right, and then Why are their eyes so small? Ooh, interesting. Let's take a look. Oh, you're right. They do have pretty small little beady eyes. And I wonder, do you think that could help them in any way? How might having small eyes help an animal? Or if their eyes are so small, maybe they're relying on other adaptations to help them to cover up for those eyes. So we see that a lot in the ocean where some animals might have one feature, like their eyes or maybe their mouth or something is a lot larger or a lot smaller, and then they have other adaptations to make up for that. So those are some great questions. Keep those questions coming, but we did get some answers to my question of who is going to be eating things like krill. So we've got the answers of whales, seahorses, jellies, whale shark, and the megalodon. Those are some excellent answers. Now, most of those animals are going to be feeding on krill. The only one that I would say is most likely not going to be eating krill is going to be the megalodon. So the megalodon is extinct, which means that that animal does no longer live on our planet, but we do know that they were in our oceans because we find fossilized teeth. Now, a megalodon tooth, let me see if I have a megalodon tooth somewhere. All right, well, I couldn't locate the megalodon tooth, but their tooth is about this big. So it's pretty massive. So that animal is going to be a meat eater, a bigger meat eater. These sharks were pretty big. They're about 40, 50 feet long. And they had these really big teeth, and they needed to eat really big animals in order to get enough energy to sustain their life. And we think that could be one of the reasons that they ended up going extinct, is there just wasn't enough food to sustain an animal that large. But if we think about a whale or even a whale shark, those animals are also can be about whale shark. I always have to mention whale sharks in my program because they are my ultimate favorite animal. But whale sharks are about the same length or even larger than the megalodon. But these animals are still around because they eat krill. So they eat a much smaller animal, and they eat this animal that is all throughout our ocean. So there are tons and tons and tons of krill in the ocean. So these animals are eating this small animal that they can find everywhere versus being a large animal that needs to eat a large thing where there's not enough of that to sustain that life. So whale sharks feed on krill, and whales, I'm glad someone mentioned whales. So right here, this is a humpback whale. And there's two types of whales in the ocean. We have whales with baleen and whales with teeth. Now, baleen are these structures right here in their mouth. It's kind of like bristles or brushes in their mouth, and they're what we call filter feeders. So these whales are going to take a big gulp of water. You can see right here, there are grooves in the throat of this whale so they can expand. Because when they expand, they can take in more water, and the more water they can take in, the more krill they're going to find in that water. So they take in all this water, and then they're going to contract those grooves, push the water out through those baleen plates, and all that krill, like those little animals we were looking at before on our document camera, those animals are going to get stuck on the baleen, and then they use a really big tongue and they just scrape it all off. And so these animals, humpback whales, blue whales, which are the largest animal on the planet, they get about 100 feet long. They eat about 4 tons of krill a day. Their stomach can hold 1 ton at a time, but they're going to eat 4 tons of krill every day. And there's a lot of krill in our ocean, so there's a lot of food for these animals. So that is a little bit about krill, which are one of the smaller crustaceans. But we're going to move on and talk about one that we commonly have here along our coasts, and that is the California spiny lobster. Now, you already know about the California spiny lobster because this one that we looked at under the document camera, this is the exoskeleton from a California spiny lobster. Now, these animals, they are generally about 12 inches, so about a foot long, but they can get up to 24 inches, so even twice the size of this. So they can get pretty long. And we find these right here along our coast. We find them in the tide pools and a little bit deeper. Now, these have a really good example. You can see their jointed legs. But what do you notice is missing from this animal? We talked about having the exoskeleton as adaptation. We talked about camouflage, blending in, and we talked about pinchers as an adaptation. But our spiny lobster, the lobsters that we have here along our coast, do not have claws or pinchers. Instead, they have these 10 jointed legs, right there, a decapod, and then they have 2 long antennas. Now, this one right here is missing one of its antennas, and that's because their exoskeleton, when it comes off their body, if we pull it from the water, it's pretty fragile, so it can break off really easily. So antenna broke off after the lobster already molted its exoskeleton. But these lobsters, because they don't have claws, they're going to have to find another way to protect themselves. So that exoskeleton helps. They also have spines on their body. Let's go over to our document camera. We'll take a closer look at the spines. So right here, they have two, it almost looks like horns right above each eye. And then down their back, this part of their back is called their carapace. And this part of their back has other little spines on it. And if you look at their antennas right here, those antennas also have spines. And so this lobster can protect itself not with the claws, but with these spines, with these antennae that they can use to kind of push animals away, or they can whip them around really fast to kind of scare animals away. So they're able to protect themselves with other adaptations than those claws. Now, you might see this little black zip tie right here. That's not found on all lobsters, but that means that lobster came from here at our aquarium. So we have these markers on our lobsters so that we can tell them apart. So we know which ones are which. Also helps us when we're feeding and identifying those lobsters. So when they molt, they are going to molt with that little tag on it, and then our staff will just add a new tag to that animal. So that is our California spiny lobster. Now we have a couple minutes left, and I want to talk about the last lobster, or sorry, the last crab we're going to talk about, because this one is the biggest crab in the ocean as far as length. So someone asked earlier in the program what's the largest, and that American lobster I think was the heaviest, but a Japanese spider crab is the longest. So take a look. What do you notice about this crab? Take a moment, make some observations, think about them, share them with someone you're near, send them to us. What do you notice about this animal? So we are looking at the underside. And for crabs, we can look at the underside right here to tell male or female. The shape is a little bit different. It's pointy or rounded to tell us male from female. What do you notice about its arms? They're really long, right? So if we were to stretch out a Japanese spider crab from the end of one of the longest arm to the end of the other, it could be about 12 feet. That is really long. That is, I think it's kind of terrifying to think about these animals being that long, but that they have these really kind of spindly long arms with pinchers too. Now, Japanese spider crabs live really deep in the water. They like really cold water, so they're found in colder climates, and they're also found pretty deep. The deeper you go, the colder the water can be. And so these animals are found in the deeps. Now, thinking about adaptations for spider crabs, what adaptations do you think they might have? Well, they have an exoskeleton, just like other crustaceans. They have claws. But what else, or what other adaptations do you think this animal might have? Can size be an adaptation? Cynthia's saying yeah. Yeah, so size can be an adaptation. Think about a little krill versus a crustacean this size. Which one do you think is going to be a little bit more intimidating or scary? I think the spider crab. And so size can be an intimidating factor. It can be something that scares off other animals. And so that is another adaptation. The big size of the spider crab is an adaptation to help keep this animal safe. But it's interesting to notice that their eyes are also still pretty small, like all the other crabs. Now, these animals do have claws, so that's another adaptation for them to use. But thinking about if they have all these adaptations, maybe to protect themselves, what would be a predator? A spider crab. Any ideas? It's got to be an animal that either is bigger than the spider crab or isn't afraid of those claws. Oh, here we've got a spider crab kind of moving its arms. One of the big predators of spider crabs are octopus. So thinking about a giant Pacific octopus, which is one of our larger octopus species, maybe we'll bring up a picture of a giant Pacific octopus. So, here we go. This octopus is one of the predators of our Japanese spider crab. So octopus have adaptations as well, and they have ways that they can get around all the sort of threatening parts of the spider crab in order to eat them. But that spider crab is going to use its claws and its size and the length of it to get away from its predators. Excellent. Now, we didn't really talk too much about what these animals eat. But if we go back and think about what do lobsters, what do crabs eat, they eat a variety of things, but I think we actually have a video of one of them feeding. And so let's take a look at that. So we're going to kind of go back a little bit, take a look at a different part of these animals, and we're going to explore what it looks like when these animals are eating. So Cynthia is going to bring up the video of a crab feeding. So this is a little crab, much smaller than that Japanese spider crab. So this is a coral crab. And like its name does imply, it lives amongst the corals. So you can see this is coral right here, and the little crab is sticking out right here. Now, how does it look like it's feeding? what do you notice? It seemed like it was kind of waving some antennas. And if we look close, you can see it again. Look just beyond these antennas. There's little arms. They have these mandibles. It's part of their jaw that they can kind of scoop food into their mouth. And so this little crab is eating plankton. It's eating whatever this stuff floating by is, and it's scooping it into its mouth. So depending on the species, things like krill, they will comb other planktonic animals into their mouth. This coral crab is clearly eating other planktonic animals as well. And then things like those California spiny lobsters, they're going to feed on worms, they're going to feed on urchins, they're going to feed on some other animals bigger than plankton, bigger than those little things that little crab is eating, but not as big as maybe the prey that a Japanese spider crab will eat, which is going to be eating a lot larger animals. All right, everyone, we are about out of time. So thank you so much for joining us today. I hope you had fun exploring these crazy crustaceans. And once again, if you have any other questions, you can email us at this email address right here, live@lbaop.org. And tune in at 2 o'clock. We have one more program today, and we're going to be learning about animal healthcare. So thank you, everyone, for joining us, and have a good afternoon.